Yes, it's done.
Okay. All right. Welcome back, everyone. Now we have a very different topic that is going to be shared by Prabhu Raut on software-defined vehicle (SDV), the future of mobility. Right. Before Prabhu comes forward, let's give a quick introduction about himself. Right. Prabhu Raut is currently head of program management at Western India, a leading US-based multinational corporation. Okay. And he's a dynamic professional with more than 2 decades of experience in manufacturing, operations, and program management domain. He's also an alumnus of IIM Lucknow, and Prabhu is a public speaker, founder member, and past president of the Toastmaster fraternity, and an ardent TED enthusiast. So, having lot of accolades in his career, with this, I want to hand it over to Prabhu Rao. Recently, he's also a member of the CXO incubator, where I was also part of that. And we used to have a very good time, right? So Prabhu, with this, I want to hand it over to you.
Thank you, Sharad.
Please go ahead.
Just give 1 minute. Okay. So Sharad, my screen is visible.
Yes, Prabhu.
And okay, we are good to go ahead.
Yes, please. Go ahead.
Yeah. Thank you, SS Agile Gurus and the team for giving me an opportunity to speak in this August forum. Okay. My topic today is the future of mobility, that is software-defined vehicle, how the transformation is happening in transportation with software. It's a very well intro already. Sarad has done for me. There's nothing left to speak about. So what I say, I started my career with an engine making company that is called Cummins. Okay, I started working on the engines, that is complete mechanical parts. Okay. I never thought of talking about software and software-defined vehicle. We all know 2 decades back, software was a very small piece in a car, right? Now software is something that is defining the complete vehicle. So if you see in the automobile industry right now is at the flux, a lot of things is happening. All all technology is coming here. Okay, one place, everything coming together: sensor, autonomous system, robotics, customer experience, video streaming, cloud competition, AI algorithm, whatever we have talked during all these sessions from yesterday. We are talking all these that the merging at a point which is in the automotive. Okay, and automotive software market is going to be triple by 2030. So this subject is very interesting, and it's a great subject, okay, to know about. It's a trending topic. Okay, before that, I'll take you through the evolution of how this has become getting into this SDV. What is the history? What is it? Let's go through the journey of time. Okay. So basically, automotive invented in late 19th century. Okay, and that time it was basically a mechanical product: gear, shaft, engine, almost 3,000 of rotating parts used to move an automobile from point A to B. And then around our fourth quarter of 20th century, the ECU comes into a picture. It's found a way into a car to control certain functions like engine, ABS. Now, new EE architectures come into the pictures. For those who are not from this background for automobile, that is electronics and electrical came into picture. With this, the electronics era has begun. Okay. And a new set of vehicle started emerging at the fourth quarter of 20th century. And now, as we are moving, now this is being taken care by SDVs, that is nothing but software-defined vehicles. As in life, this comfort, entertainment, and safety has taken away this need of new era. And as the silicon part started coming into the picture, and we require more compute powers, And that's the genesis of software defined vehicle, and that way it has started. So mechanically it is started. Okay, it moved to ECU when ECU started driving this E architecture, and on that it is moving now to SDV. So basically, I don't call this transformation or what is getting moving as an revolution. Basically, this was something, and the evolution of that has started. So mechanics part E came into the picture, and then SDV came into as a vehicle one. Now, what this software defined vehicle, why becoming so important? Okay, so if I have to answer these questions, no other industries like automobile undergoing such a rapid technology changes as the auto industry, right? Earlier, software was assisting the software to a car, right? But now this software used to be part of a car, but now it so helps to differentiate the car. Whenever mechanical parts already got reduced, and while software parts got increased in a vehicle, okay, and the microchips requirement and everything has increased, okay. Now these days, this electronics contributes to 40% of the vehicle cost. Okay, around over in premium vehicles, some over 3,000 microchips are there in the vehicle, and this is so software intense. In a vehicle, around 150 millions lines of codes are written. It is like an airborne flight that intense. The new days cars are being produced. Okay, and 40% of car cost is going through the electricals and electronics and semiconductor industries. Okay, and as the evolution started, we started moving from mechanical to ECU driven, and then to the software driven. All the regulatory requirements came into the picture, and safety, and that's why there are more numbers of vehicles on the road. So then everything is started, how they will communicate, how they will move, how to control, and this has started coming to the picture. So I'll take you through these are the topics what I am trying to cover for the software defined vehicles, like what are the key mega trends, okay, and what is the life cycle of a product. Okay, we will be covering this vehicle architecture, how this is evolved, and earlier architecture will stop you from going to a software defined vehicle, and we will go a little bit delve into the hardware and software stack, key challenges, future ahead, and summary we will do. If you see earlier when people used to go dealer location or thinking to buy a car, the main questions they used to ask it, what is the horsepower of the vehicle before every purchase, right? How much pull it can provide, what is the mileage, right? Now this discussion has really shifted. Okay, a person when he is buying a car, he is more looking towards what are the features that car is going to offer me. Okay, what sort of autonomy the car will give me. Okay, what sort of safety requirement, how many safety bags are there, is there any automatic emergency braking is there, whether it's a ADAS level, what and all. These are the questions the user is asking, and this is the software is on the core of implementing all these things, right? So now the vehicle has really moved from hardware based to a software based. Okay, and now these days these cars are basically, you can call mobiles on the wheel. Okay, and sometimes people call it's a living room outside your house. When earlier, now these days people are taking their calls, their Zoom meeting, even their offices meeting through car, because this is possible because with the advent of this technology, the comfort of home you are getting in the comfort of your vehicle itself. All this requires certain changes, and the current architecture what the vehicle have, let me delve on that. Okay, so current architecture of OEMs is basically there's a domain controller, right? That is managed through a ECU. Okay, so this is a typical architecture. On the right side, you can see that this is a typical architecture of existing car. Okay, so this is basically multiple ECU connected over CAN, and this signals gets processed, And these are the domain. This is like powertrain, body, connectivity, ADAS each. And domain-based centralized architecture with a gateway, this operates. And what this gateway does, it talks to each other, okay? And these are the standard domains. This is the current architecture of OEMs. And the future requirement based on the need is going to change. So what are the features need, if you see, okay? The future vehicle needs commonly in automobile is talked as case, okay, where case stands for connected, autonomous, shared, and electrified, right? For any industries to evolve, to grow, the demand is the main criteria, okay? Product is being always created to satisfy customer need, okay? And it does not happen other way, where once there is a need, then the product get introduced. But in some cases like Apple iPhone and all that, first they create the need and then it goes to the market. But most of the time it happens that the need is there and then the product gets introduced. So now what is the need of a person is to be connected, okay? And they want an autonomous means, and this is shared mobility area. And electrification, that is something going. Now peoples are getting a lot of personalization. Even the car they want that car to be personalized. My car and your car should be different, right? It might happen that inside of the car is the moment you are entering into car, the a cockpit things gets changed and it's become your personal choice, your personal mood lighting, and everything has come into the picture, right? And this is the requirement. Sometimes it might happen the car what you are owning that will behave throughout a month, a week, say 5 days a week, it is behaving like a office going mood, and in the weekend it gets converted into a weekend mood. And the same car having two or same OEM and two persons, and they should have a different configuration. And this is only possible through software, okay? Hardware has limitations, okay? Car is basically now these days, it's an extension of your personality. This is no more a thing from take you from point A to B. And that's what this personalization, this connection requirement is bringing you to a new era where this development and everything is happening. And this is the place where we are getting new requirement, and then OEM is trying to fulfill that requirement, and that's the genesis of this software defined vehicle. Two of the major trend what I see as electrification and software electrification that is driving it much. It must. What happens is once we moved from ICE to electrification, this the constant power supply sometimes making things happening very good way. There is no constant power supply makes things very good for operating a software defined vehicles, right? And the cockpit of is totally getting changed. I belong to a company which is the leading manufacturer of a cockpit, okay? And you see the screens are becoming part of a car, because there needs to be a computation and everything, then only the vehicle will get connected. So all those computer like screens are coming part of a car, right? What the word is being used is the screenification of the car is happening. In the picture you can see how end-to-end screens are being deployed in the cars. Recent Mahindra one is having 10.25-inch two screens, right? The infotainment and the cluster. And you can see in the image as well, there are pillar-to-pillar screens are there, okay? And these screens sometimes called DID, PID, and CID, right? I mean, driver information display, a central information display, and then the passenger information display. So all this cockpit is being is actually changing, and this can be done. This is the genesis of this software defined vehicle. Okay, in the cockpit there is a voice that is getting earlier used to be a touch based. Now the voice recognition, Alexa, and based on the OEM, MG has got his own one, and Mahindra has got Alexa and Siri, and everything is coming. Android Auto, CarPlay, everything is coming to the picture, and this is the trend, this is the need, and that's what everything is going that way. And next generation of electrification has people, the CO2 carbon neutrality and everything. We need to come into control the environment, and that's that's the place where we are moving from ICE to electrifications, and sometimes this is government regulated also. Although this is in nascent stage, but this is the future where we are going. And in this the compute power and everything is required in order to control this total SDV vehicles, and that's what everything is happening. Okay, in ADAS and everything, I'll just take you through ADAS level, right? So most of you must be knowing in ADAS this level 0 to level 2 plus, that is right now in production, right? This is the level of autonomous vehicle driving, right? In level 2 plus, where a driver supervised system, and it can if the lane assist system is there, without if you can take it your hands out from the steering wheel also, it can move, and that's the level of autonomous is happening, right? And the level 3 and level 4 is actually level 3, some of the Tesla cars is in level 3, and level 4 and 5 still team is working. But again, that is also possible to move one vehicle from point A to B without any driver assistance, and the system takes care of it. That is also happening only because of this software definition. Without software, this is impossible to do, and that's what autonomous vehicles coming into the picture, and that's where it is sometimes defining how the future will be. Okay. Now, I'll just little bit speak about the evolution of our cockpit domain. So if you see, the cockpit is from where the central computer, everything is working, and the car is being controlled, right? And if you see the cockpit, how it is moving along with the time, with the technology that is getting introduced, the technology which is growing, and what technology has got matured and what is declining. You all remember in our car till this time that there is a audio systems that used to be very button a short of time, where you used to haptic and all that we used to do. Right now those all things are basically slowly is getting extinct. Now it's a digital one going analog, and everything has got this button and everything. Now it's a digital cluster that is across the world. It is moving at a very fast rapid rate. India also, all the premium vehicle manufacturer like Mahindra, MG, Hyundai, everybody is using. Maruti is still coming a little slow because of its Japanese origin, but others are going fast, and this is some digital cluster right now in the maturity phase, and that is happening, right? And the growth zone, what is coming on the growth zone is now all Android-based infotainment and large display. The display is what I showed you from pillar to pillar, right? And this electrification, app car, ADAS, this is something which is getting introduced into the a cockpit, and this is driving actually the complete vehicle, right? And in order to ensure that while you are driving the car, there is enough a safety system. All these screens should not disturb each other. There are a lot of technology that has come into the cockpit. There is some active privacy where passenger, if watching some video or something, the driver cannot see. Okay, those type of safety measures, everything is being placed, and this is again this through software. Okay, it's impossible in that mechanical era that what we can do. So if you see how that from the legacy and how we are moving towards, you will find that earlier the vehicle really it was a hardware defined. The legacy vehicles have a architecture where the software content was very less. Okay, until 2017 there's not much, right? But slowly we started moving towards a domain controller. Okay, that ECU and everything is coming to the picture, and that way they are controlling it, and the compute power centralization up integration has started happening. And the zonal architecture is something where you can control zone wise area of optimized you can optimize the whole architecture, and this is zonal one where right now the automotive world is working. And going towards SDV is required HPC, that is nothing but high performance computing. You should have a compute system where you can do computation through over the air, and in fact in intelligent edge you can do outside, and those compute when you brought to the car. And that's way the moment the revolution actually has happened when the connectivity has really increased, where the all the computation and everything can be done outside the car, and the results can be brought into the car. So scale up to the cloud is happening, and cloud is coming into the picture. The way your mobile is connected to the cloud, there is over the air updates and everything is coming. The same way the car screen and everything is connected to the cloud, and all computation and everything is actually happening. So what I would like to explain now, that what is the architecture and how this is architecture is right now not helping, and how we need to move to the next architecture system. So if you see the architectural right now, what the software and hardware has, software has a monolithic architecture. It means one software say on one domain it is happening, and they are not talking to each other. So what happens if there are some changes needs to be done, it needs to be done a particular software is specific. There is no communication happening between software to each other, right? And hardware also, as I explained, this is distributed EE architecture. Okay, and this monolithic and distributed architecture is not helping the migration towards SDV. And what is the need? The need is now to have a microservice architecture when the services is provided by the particular software, and the software should be able to communicate with the fellow software, whatever has been provided the vehicle, and this should be run through a central compute and zonal control. When the compute is there, and that has an ability to interact, and this will really help over the air loading of the software on the vehicle at the same place at the same time, right? And this central compute adaptation only is going to provide this SDV. And there are a few OEMs which is far ahead in this, and there are still few OEMs that is they are lagging behind, right? So as I explained, this is legacy architecture, and now right now we are working in the partial SDV mode, and we are going to move in a full SDV, right? And legacy architecture has some advantage, and but the full SDV has that scalability options. Okay, once your vehicle earlier what used to happen, the moment the OEM has sold you a car, the relations between you and OEM used to break at that moment. But now these days, after the vehicle is released, you purchased, and after that also there are a lot of features, new features getting developed, and those features can be implemented in your car through over the air transfer. And that's where those there are subscription based software and everything is coming to the picture, applications coming into the picture. So those things are really now the relationship between the OEM and the consumer is not happening, and this is something they are going to monetize also. This is the new trend that is happening, subscription based model. And these are the base, it also helps you to your diagnostic and diagnose the vehicle and correct from a distant place, right? Right now if you see, I'm in a industry where we are developing software, then there's a software version we are giving to customer is taking it, they are operating for certain times, then we find that there is some bug fixes, there are something new to be introduced, and then we do over the air transfer to that OEM, and that is being fixed, right? And there is a subscription model also in India that is running right now. Okay, so see, this central compute is going to really help, and HPC is something, high performance computing is something that is going to change everything. And what is the differences between this legacy and full SDV? The physically what happens is that the reduction of number of issues will happen, and that is happening actually because of the central compute system. And the wiring harness is throughout the car. If you see that wiring harness, that is getting reduced, and it is very, so that complexity of wiring harness is getting reduced. Okay, and you must remember earlier we used to have the war on the weight of the car, right? We used to reduce the weight of the car, but now with this HPC and electrical vehicles, actually, okay, the war is on energy consumption is happening. If you reduce 1 watt, that gives you a better range. Okay, and that's where you have to look at the every opportunity where the energy consumption can be reduced, and that's where when the vehicles will be a full SDV, the wiring harness and everything will come to a lower side, and this is really beneficial for increasing the range. And every OEM right now working, some or the other days we are getting news that this EV, earlier it was having a 300 kilometer range, now this is 400. Now recently I saw one vehicle that is claiming 57 Volvo 570 kilometer range. So you can understand how these things are moving at a rapid pace, and this is happening because of the software development, and the software development itself. The industry is, earlier this industry was only a part of a mobiles and consumer goods, right? But suddenly it's taking a space into automobile industries, and the difference between the automobile and the consumer goods is, consumer goods is static. It is not operating on the not moving part. So anything goes wrong with the software running vehicle on the road, then the life threatening situations are there. But in case of consumer goods, it is not that. That's why the software stack and everything is very important. And how this software stack is happening, if you see, right, there is one application layer, then there is a middleware and services, and then it's work on certain operating system. Okay, and this HPC and hardware is the base. And what are the components that is helping is for hardware, actuators, sensors, and HPC side, domain controller, zonal controller, and these operating systems comes as a Linux and QNX and build library. And this is the application layer that ensures that whatever application you have installed in the car, that talks to you or operate with all this 5G supportability, and the stack is like this. Okay, and this application talks to you, and now this is basically a sort of a smartphone. Okay, so this automotive software is very safety critical. That's why a layer of safety is getting added to this again, and this is getting complicated day by day. What is happening, the hardware part of the vehicle, which used to be 3,000 parts, those moving part as the electric vehicle has come, has been reduced. Now the engine itself used to have thousands of parts together, right? And that becomes a battery pack. Then everything has been reduced to fewer parts. But at the same time, to operate all those software, what is needed, that is increasing, and there are a lot of codes and everything is coming to the picture. Okay, number of suppliers for hardware components are getting down, whereas the software suppliers are increasing. And this layered architecture, what I am showing, is a little bit complicated for those people who are not from the software background. But this is like a smartphone architecture. In that way, it's happening. And if you want to see what is that, how this correlate to the working, there is external interface. When you talk to your system, your like mobile app you are talking to, that is there, and that is connected through cloud. Okay, so cloud car API is working, and that helps you in infra management and all, right? And cloud is now these days is as a companion for infra management, right? Without cloud, the vehicle needs to talk to others. It is not possible, right? And the software application this voice V2X, where they need to talk, okay, to other thing on the roads, right? Say electric vehicle is going, so they need to know at what distance, which part the next charging station is there, right? They need to compute what is the range available, and this can not be done only on the car. That needs to be done through a cloud, and that's what the role of this software application and everything comes. And this works on a software platform that and this now, as we are operating in 5G, and now recently I was hearing that 6G also is possible. Right now they have started working, Nokia team has started working on 6G, and this revolution, what I call, into this network, and this latency and everything is going down, and it's a real time something is happening in a safety measures and everything, where the communication needs to happen with the car and user. You can't afford a lag there, and that's where the genesis of everything is happening. Okay, and the hardware, what hardware role is playing in this is like HPCs and zonal controller, right? And this basically, if you see, sensors, actuators, and displays are helping into do this hardware platform. And all these things are very safety critical. In the consumer electronics, it is not like that, but when it's come to the car industries, the cyber security and functional safety is one of the requirement, and that requirement needs to be made through this tech stack, and that is what happening. And now every vehicle manufacturers, OEMs, they need to decide their strategy, how they are going to move to a software defined vehicle, because some they need to. And in order to do that, what some of the OEM, what they are doing is they have extended software. So that they have basically a task based approach. Okay, so what they are doing is the software development outside they are doing, and this is a tactical one, right? And there are few OEMs, they are using a software as a commodity, like a self component software that is they are purchasing and they are using in their cars. And some of the company, what is they are doing? They are doing a strategic partnership with software houses, startup, and creating a software. And this is the third one is moving. This is basically a circle where you need to, what is your final goal in order to be a SDV vehicle? The software should be as a core of your business. The final and ultimate goal is to software as a core business. And for few of the OEMs have understood this, and they are trying to build up software in-house with network of partnership with the software houses. Expert like Tesla is enabling disruption in SDV market. Okay, and there are some of the automotive company becoming the software company. And if you software as a commodity, it is you will not be able to do that, because it has to constantly evolve. There are a lot of deliberation, lot of discussions, a lot of definition of what is going to happen, how to what is the requirement. And when these two people are working together from outside, then there are a lot of delay, and that is happening. So that's the reason if you find Tesla and all, they are they are in the software side. They are becoming because moving faster because they have their own software development facilities, where the other OEM are still struggling. I'll take you through a chart where how the ranking is and everything is happening. Let me first take you through the what are the challenges of this software defined vehicle. Okay. One of the greatest challenge, because you are connected to cloud, okay, and then cyber security management, okay, and I because this is AI is also playing a role. There are a lot of codes is happening, okay. There is more complex structures, and this is continuously growing. So how this management of this the codes and everything it's increasing day by day. That is a challenge. At the same time, the cyber security of that is a challenge, right? And this OTA it is not well distributed still, this connectivity, and the sometimes that gateway and everything is a problem. And this basically right now a very challenging one, right? And finally, this total cost of ownership, right? How a vehicle, because once it OEM is building, and then is still they need to provide connections, and they still provide the software updates and all that. So how those maintenance and total cost of ownership is really challenging. And whatever, if you are putting a voice system into a car, even sometimes the dialect, the language, sometimes you need to understand if some car is operating in India, what sort of communication it will happen, and in other countries, what are the language barriers, and everything is there. So even if you develop something, a voice enabled here, how it will function and how it will be scaled, these are the some sort of problem that is happening. So localization of a technology what is developed worldwide is a challenge, okay. And the safety security is something, software defined vehicles, if fails on the road, that's a really problem to fix up those vehicles. Other than earlier, it was used to be hardware defined vehicles where so few mechanics used to do it. Sometimes it really challenging, and but there are a lot of work going behind on this, okay. And there was recently one award intelligence has released for 22 OEMs, the automakers who is in this business of software defined. I mean, all OEM has to move towards this. There is no way you cannot go along with the trend, the mega trend, whatever I have explained, okay. If you will not join this through this, what will happen? Some other day you will be losing the business. And this graph, what you can see on the screen, and that is saying all, okay. Right now on the leaders, this report has just released last year, and it says that there are leaders like Tesla, Lucid, Rivian, these are the leaders in the SDV, okay. And strong contenders are someone who has a plan, but still they are in a semi SDV. They have not moved to a full SDV vehicles. So BYD, Volvo, and BMW is a big name in that. Polyester and Jacker is still financially not that stable, but these companies are stable. And this chart depicts not only the software ability and their financial stability, and there are so many parameters based on this. This chart has been prepared. And contenders are OEM yet to launch on their next generation platform for semi SDV. So they are lagging, but they are contender. They have got the muscles power. They have got the money power in terms of muscle power, what I can say. And these are the something they will bounce back. They are coming, and they have their strategies to go to SDV, right? But if you see the last one, the followers is basically Japanese OEM, where they are basically more in making sure that status quo they don't leave faster. And that's the reason, if you see this Toyota once used to be a big the number one, slowly it has come here because they need to pick up. If they don't pick up it, the trend, their businesses might suffer. And these are the automakers that they are going to be in this game soon. Okay. And so what actually I try to discuss is these are the summaries. Okay. Software quality requirements in automotive industries is very higher. Okay. Compared to any other industry, safety is critical as the vehicles are on the road and in the motion. Okay. And the functional safety is paramount here. Failure is life threatening and software needs to go through hardening. What do you mean by hardening? In the those who are from the automobile, automobile on the hardware side, they can understand the metals being hardened. The software hardening means how much it goes through the testing and everything and make sure that it never fails. That way that is happening, and making sure this is tested well and coming, and these things are really needs to be done in a right way. And this organizational transformation is actually supplier and OEM relationship is changing, right? In automobile there is a OEM, and then there are tier 1, tier 2, tier 3, and it used to be tier 1, tier 2 wholly dependent on OEM, but now these days what are the tier 2 1 and tier 2? Because this is silicon based, now the chip is there and the chip is being used in the television, also other places, consumer electronics also. The supplier of that is actually basically the supplier of that is they're not dependent on the OEMs, and that's where the total control on OEM on this is really having a challenging. And you people might have heard this chips crisis, and the chip crisis that happened when in the COVID time, where the consumer electronics goods has increased, and all this chip manufacturer started meeting the need of those um, and consumers good, and that time this automobile business has come down, and because of COVID there is a slump, and this what they have done, automobile makers, is they reduce their ordering to this chip makers, right? And whatever the consumption the chips were available, that has moved towards the, because people when they were in the COVID side, they were using more screens and everything, and then there was the PC, laptop, everything demand has surged, and that has created a void. So you see there was a very sort of recession that has come in automobile side, because there were the chips that were not there, and there was a Taiwan factory, TMSC has some fire and all that, and that all thing has compounded and somewhere impacted the automobile industries, right? So why I'm bringing this one is, earlier the software hardware structure was a tier 1, tier 2, and they were integrated, right? But now in between, the suppliers that are coming, they have got other priorities also. So how this is going to evolve and how it is happening, sometimes this is really a challenge, and new norms are getting placed in this way. Okay. And so a traditional partner like NXP, NSS, they are also supplying to other places. Okay. And this cyber security, cyber hygiene, and data protection is really getting challenging. That we are advancing on this. Everything is on the cloud. Your information is on the cloud. Your personalization is on the cloud, right? So how, when we are making software, we are making sure that each places it is safe, and the safety code has been inserted, so that is the cyber security part is taken care. But still there are few places where this cyber crime is happening, where they have some few controls of the vehicles, and that is really sometimes threatening. But again, the evolution will happen, it will not stop, and things will move. We need to find our work in and around this. Okay. And how this can be made possible is software development actually is happening at a rapid pace, but every company, and they are trying to develop their own. But till the time there is an open source, if it is not came into the picture, where you can open whatever software you develop, right, that is available for other companies to build on that. Every time reinventing the wheel will actually not help. Okay, so what you need to do is we have to embrace the OSS, that is open software. Okay, actually that helps to develop software vehicles, and on a short span of time, the software development and everything will happen, and that should go through the agile methodology, and at the same time DevOps approach, where it is built, tested, and then move forward, so that this can be used for other people, right? So OEM software capability development, the new talent what is coming into the market, that is software oriented, and the mindset of from hardware centric to software centric, that is going to happen. So at the day end, this is evolution that is going to happen. We are going from a mechanical to a software centric market, and this is all about user experience. This is user driven, and we have made a great progress in that, and we are going to make more progress in that. And the future of mobility is software defined vehicle. That's what I have for you. Thank you very much for this patience hearing. I'm okay for few questions. Thank you very much.
Yeah, thanks, Prabhu, again for a wonderful session. Now, these kind of topics we rarely hear, and they used to read some articles, right? Other than that, if you want to get real insights, obviously people have to join these kind of sessions to get that complete flavor and where we are in the market today, and what are the different strategies that we need to adopt to ensure we reach the next generation, next expectations, right? So with this, let's open up for Q&A as Prabhu requested. Any questions from anyone? Okay, let me see in chat if there are any questions. Just give me a moment. No, I don't see any questions. Okay, so Prabhu, I have a question, right? With respect to this SDV, even though we are trying to make more impact with respect to the kind of software that we are trying to use for the next generation, what is its impact and origin in India? I see a lot of Teslas, this and that, right? A lot of other countries trying to make a difference. How about its impact in India?
India is actually very much ahead in this. The world is getting software that is built by India, actually. Okay.
Oh.
If I take my example of my company also, the software heads are sitting in India, okay, and they are making sure the world is supplied with all the required software, okay. Tesla is something they have got their in-house software, and they are ahead in this. There are a lot of things doing in this one, but all other than Tesla, everybody is lagging. You have seen the chart and all that. And in India, actually, the OEM like Tata Motors and Mahindra with the XUV 7.0, they're level 2 plus. MG Hector, this is level 2 plus. And recently, just before this, I was watching on the TV that Mahindra is going to launch Born EVs. Okay, and that is completely software defined short of, because the platform and everything is changing. In the Tata Motors side, the Nexon and everything is on the legacy platform, but these companies are working on a platform that is going to have a different architecture, on which they will be able to build their platform and can scale up. And that's what the Born EV concept is being brought by Mahindra, and somehow Tata is working on this. So there are a lot of traction happening in India, and India being a software hub, and this is controlled throughout the world through the Indian talent only, sir.
It's a great answer, Prabhu. Thank you. And how you see this evolution? I saw by 2030, the revolution is going to reach its peak phase, right?
Yeah.
So we are already in 2023. I know there is good amount of years, but what are the challenges that you see with respect to adopting these software, new softwares into the vehicles? Do you see? I know you have covered the security challenges part also, but can you help us a little bit more deeper understanding on this?
Okay, so basically challenges are a lot. Okay, and that's what I said, the open source software. Okay, till the time software is not democratized, I mean there is something built, and then on which you do have to know, you don't have to reinvent. You can build on that, right? You remember in the past, the safety belt has been somebody has developed. Okay, and that they have not taken a patent of that. Okay, they have made sure that everybody uses because they're safety critical. And if you really want to move in a software defined vehicle, and there is software that is going to define everything, right? And if you don't do that software open source, and everybody is whatever they are developing, they are keeping with us, then it is still a long way to go. And if you see the 2030 somewhere, that's electrical vehicle carbon neutrality. A lot of companies has claimed by 2030, and they will be only making EVs, or they will not make ICE and all that, right? This is carbon neutrality is in order to save your planet, and everything needs to be done, and people are doing that. But 2030, whatever the data says, it will not be possible. It may be a 50% penetration or 60% penetration. So SDV also will take a longer time. You will be able to develop few vehicles. You will develop a car which will go from point A to point B without a driver assistance. But is that scalable? Okay, it can be a mass production. It can be produced as a mass. That is going to take a longer time. I say it's maybe 10 to 20 years as per my experience. I may be wrong, but this is what I can say right now. My gut feeling.
Obviously, there's a lot of untapped market, right?
Yeah,
Which we can explore.
yeah.
But that's like a oxygen for all the companies. I hear some other voice. Anyone wants to ask any question?
Yeah, I have a question
Please go
to
ahead.
Prabhu. Hi, first of all, wonderful session, Prabhu. It is really
Thank
out
you.
of the box for us. We have been blown with all the agile methodology, all this file. All the sessions are about agile, but he suddenly took us into the virtual car. Now I feel like I'm sitting in advanced car. So my question is, how close this software development is picking up in terms of airlines? Because we see airlines is also more in terms of development in software. What can we see in tomorrow? Either airlines is similar to car, or car is not airlines. Because the console itself is different right now.
Yeah, so there is everything. There is a little bit of software, okay, whether on the road or on the air right now. And I said there are 150 millions of code is being written in order to move a car on the road, and making it autonomous level 3 and 4 safety, security, and everything. And the same way in the air also. So both the places, the software is there also. This is working there, and numbers of line code is on the road. It is more because the way it is interacting with the uncertainties on the road, that much not uncertainty not on the air. There is a once you predefined and everything, it's moves that way. So basically that's why I said in my presentations, and that the number of code is being written is whatever is going in the air that way itself. So number of actually what is the number of codes and everything, I'll not be an expert to answer that numbers, but I can say sure that this both is going into same way, and whatever the air has got, the more than that, this car working on the road has a software codes that is happening.
Thanks, Prabhu. We have a couple of questions on YouTube as well. What about the sustainability aspect and the regulatory aspect?
Yeah, that is actually sustainability in the sense this is the one of the mega trend. Okay, this electric vehicle that is going to help this carbon neutrality. Okay, and that's what is happening. Everybody is behind that, and I said because there is a constant power supply in EV, and that is the trend that is going to happen. So it's really going to help in sustainability of the nature. If you are asking a question, how much sustainable it is, then answer is right now people are feature crazy right now. Okay, everybody wants so many features. Okay, mood lighting, I want this and that, but at the day end, what happens is this market is going to get matured. Okay, you will need only a few applications for your safety. You need applications. You want a music to play on the dashboard, and many very less features. And this will consolidate. Right now, there is a flood of features coming to that, and this is really this will get consolidated, and the sustainability of this type of vehicle is going to happen, because and it can be scaled as well. As the software and everything gets matured and open source and everything will come into the picture, I'm sure this is sustainable over a new time it is coming, right? And this will phase out the way the mechanical engine part has phasing out, the way everything else will phase out, and you will go to in a software defined vehicles in coming days. Okay, everything is defined by software, nothing comes from here and there. Yeah. Yes, Satish, I think you are on mute.
Any more questions, Satish? Or
Yes, that's the questions. We have, I mean, few more things which the participants on YouTube want to it clarified. You will share your LinkedIn profile so that like they can get in touch with you and they can get it clarified. Prabhu.
yeah, that's great. Thanks, Satish. Thanks, Prabhu, for an excellent session. Again, a little bit token of appreciation from our side. Let me try to showcase my screen. Just give me a moment. Okay, hope you can see it and others also can see it.
Thank you very much, Satish and Sarath. I not expected this.
Okay.
So thank you very much.
First of all,
It's a-
we have to thank you for being part of this, despite your busy schedule, right? And I know the kind of efforts and pain that you might have gone through while preparing these slides, giving us live feed of what are the trends and how things are going to shape up in future. So a big vote of thanks for you. And as participants already told, it's already become a great session. So thanks, Prabhu, once again for a very good session. Okay.
Thank you very much.
Yeah.
Thank you everyone
Thank
for
you.
listening me
Thanks.
patiently for such a longer time. Thank you
Thank
very
you so
much.
much. So with this, the session from Prabhu has come to an end. We will start off with another session, right, Satish? Or it's a back-to-back session to one, right? Okay. Let me see. Just give me a moment.
And now we have Satyajit.